Hey guys, Dr. Brown here, and tonight we're working on an integration problem, the integral of 2x minus x squared over e to the x. Now you know our tools. If you follow the channel, U sub, trig sub, integration by parts, partial fractions, power reduction, long division, completing the square, and something I call method of quadratics, just a method to separate those terms out. Okay, so in this case, let's bring this to the numerator first. E to the minus x dx. Let's do that. Okay. Now let's distribute that. I have the integral of 2x e to the minus x dx minus the integral of x squared e to the minus x dx. So all I've done is move that e to the x to the numerator and distribute it to each term. And for me personally, I like to separate out the integrals. It just helps me not lose track of what's going on. Okay, you may not need to do that, but I do. Okay, now of our tools, what tool do we have? We have multiple terms here. So I think integration by parts would be the tool that we're going to use. Now I love the DI method. I would encourage you learn the DI method. If teachers are still teaching the old method, which it's exactly the same thing, except the DI is a tabular method that allows you to not get lost in the whole thing. This is a perfect example of how well it works. I would encourage you, work it with DI, work at the other method, you'll be a converter. I was, for sure. When I first saw DI, I thought, oh, that's just a gimmick. Well, it's not. It's a way to organize yourself. So it involves plus, minus, set it up like that. There's one column for derivatives, one for integration. Of the two terms, pick out the one that you know you can integrate. E to the minus x is the one I'm going to choose, okay? And put 2x here. So that's e to the minus x dx. We're going to integrate that, take the derivative of this. Now there's three stops in the DI method. One of them is in the derivative column. If I get down to where it goes to 0, that's a stop. Okay, and then the other stop would be when you get a row that you know you can integrate, that's a stop. Then the third stop would be if it starts repeating itself. That's a stop. Okay, so in this case, you know, the integral of e to the u du is e to the u. So in this case, I would have minus e to the minus x. If I integrate that, the negatives cancel, e to the minus x, and then minus e to the minus x. So take the derivative here. Derivative of 2x is 2. The derivative of 2 is 0. So now I look at the diagonals. Well, I don't need that last one, do I? Okay. So I'm going to multiply those diagonals. Positive times negative gives me a negative 2x e to the minus x minus 2e to the minus x. Then I'm going to integrate that row. Well, 0 times that, it's just the integral will give me a constant of integration, so it's just a 0 for our purposes. So I just immediately did that DI method for that integral, and there it is. Okay, now I have this one. DI plus, minus, and I'm going to put this negative x squared. I don't want to lose that. E to the minus x. So now, if I integrate e to the minus x dx, again, it's minus e to the minus x. Then the next one is a positive because the negatives cancel each other. Minus e to the minus x. Okay, so let's take the derivative of this. So it's minus 2x and then minus 2 and 0. So again, look at the diagonals. Okay, if you integrate that row, obviously it's 0. So what do we have? Positive times negative is negative times negative is positive. So I have a plus x squared e to the minus x. Negative negative is positive, so plus 2x e to the minus x. Negative negative, so plus 2e to the minus x. Okay, so I now have a negative 2x e to the minus x and a positive 2x e to the minus x, a negative 2e to the minus x and a positive, and I'm left with this, which is x squared e to the minus x, or that's x squared over e to the x. And that is what I should have gotten, because we performed a derivative on that function earlier, and or derivative on this, and had gotten that function. Now we're integrating that function, get back to the original. Okay, DI method. It's a great tool. I would encourage you to go to YouTube and look for black pen, red pen. The guy's phenomenal. And look at some of his videos where he has 100 integrals that he's performing, and then just let him show one, pause the video, try to work it. The guy is an extremely talented individual. I couldn't carry his eraser dust. But anyway, I learned a lot watching his videos, and hopefully these are working for you. All right, why are we doing this? Together, we're trying to build a better tomorrow, and do that how? Do that through math. Keep studying. We'll talk to you next time. Thanks.